Hello, this is video number 45, and what we're going to look at in this one is a trace of example 1. ex1.py. That's one of the example programs I've emailed you to so far. Example 0 wasn't terribly interesting. All it was an illustration of all those arithmetic operators, the multiply and divide and all that stuff. Example 1 has a little more meat to it, so when we trace through that, we'll need to be careful and keep up with everything that's going on. I'll just split the board. Over here, I'll put the actual trace. Trace means you just keep up with all the variables that show up in the program and keep up with their values as the program executes. In other words, you're keeping up with what's going on in the memory of the computer while the CPU is running the program. Over here, we'll show the output that goes to the screen. So a trace like this has two parts. It starts with output to the screen. There are not any variables yet. Well, I jumped the gun, didn't I? Starting with line 1 at the very beginning. Please use a header block of comments like that with the Python programs you turn in. In this case, I've got the file name is example1.py on line 1, then my name and transeu, and then the course and which semester we're in, Fall 2020 Module 2. Then at the top, you put a brief description of what the entire program is about. You're not talking about just 1 or 2 lines, you're talking about the whole thing. In this case, it's chat with the dog walker, and this illustrates basic use of several Python statements. So there, and a nice, neat little package at the very top tells us just about everything we might want to know about this file as a whole. Now then, line 9, def main. We know what that does. That says that's the start of our program. And I'm going to pretend that the CPU has already read all of this program into memory. And now, in fact, we're actually doing line 41, going back and executing it. So let's execute this the way the CPU would after this program's been loaded into memory. First thing it'll do is print a blank line. And to show that there's a blank line, I like to use a little arrow like that. It's like a return or a character return or whatever, the enter key, just to show that the output's going to start after a blank line up here. That's what line 10 is for. It's just to make it look a little neater on the screen. Skip a line before you start printing stuff out. Line 11 actually prints something out. Python statement demos. Like so. So it just prints it out verbatim. In other words, exactly what you get is exactly what you see. And then another blank line so that the title that's printed to the screen of what this program does, it's separated from the rest of the output there. Then you can put blank lines in your source code just to make different sections of it stand out and make your code easier to read. So line 13 is there on purpose, an intentional blank line. Now the inline comments, the comments that start with a pound sign all throughout the rest of the program, starting with line number 14. Those are not talking about the program as a whole. They're talking about the next 1 or 2 or maybe up to 10 lines, who knows. But they're talking about the next section of code and what it does. In this case, line 14 says input of a string. And in fact, that's what's going to happen. Line 15 is actually something that's going to execute. It's not a comment. It's not just a blank line. Line 15 is a special case of an assignment statement to read from the keyboard. We've seen that in a previous video. It starts on the right-hand side, since it's an assignment statement, line 15. Input, how are you today? What that input statement does is it actually goes both directions. It prints out that prompt to the screen and then sits there and waits until somebody types something in. So the output is going to be, how are you today, colon space. I also like to explicitly show spaces there to remember that a space was actually printed out. Now then, it's just going to sit there and wait until the user types something. So I'm going to be the user and the program here and pretend that the user types in green. I'll show the user input in green to distinguish it from what the program prints. They type in, okay, I guess. And then they press the enter key. The enter key is what sends what they typed in, the string they type in, that's what sends it into the input statement in your program. So now I have a value on the right-hand side of line 15, and that goes into variable response. The first variable to show up here is a variable called response. I'm still on line 15. And since it's a variable, it's a string variable, it can hold a lot of characters here, so I made it nice and wide, and it's open at the bottom so I can cross it out and put a new value in if a new value comes along later. Okay, so far what's happened is the input statement printed out on the screen, how are you today, the prompt, and the user typed in okay, I guess, and pressed enter, and the okay, I guess, after before the enter, that's what's read into variable response over here. So it's going to be okay, I guess. And we've read from the keyboard into a variable in the program. Then we turn around and use the value of that variable, and our program will print out, I'm glad you're and then it closes the double quotes, so it's printed out, I'm glad you're verbatim, and then it prints out the value variable response, which is, okay, I guess. And then it finishes up with an exclamation point. I'm glad you're okay, I guess. Now, that's all of that first little section. That's just reading from the keyboard and printing it right back out. Example of that. Then the blank line number 17, you will, by the way, you will want either a paper copy or to have a window open with this program in it so that you can follow along line number by line number to see what I'm talking about here. Line 17, that blank line is purely for cosmetic effect, just to separate up the code to make it easier to read. Line 18 says we're going to read in a number, input of a number. So here we go, another assignment statement. Now there hasn't been a blank line on the screen since it printed this out, so this will go on the very next line. Line 19 also has an input statement, but it has an eval out front. Remember, that's when we want to read a number. And now it's going to print out, how many dogs do you have? Question mark, colon. How many dogs do you have? Question mark, colon, and there's a space in there as well. If you put a space inside the quotes as part of your string, then that space will print out as part of the string on the screen. It's a tongue twister. How many dogs do you have? And let's say the user types in 2 and presses enter. I would do more, but I'm afraid I'm going to run out of board space here. When they type in the 2, a couple of things happen. It reads that in as, first of all, as a string, double quoted string, by the input library program, and then it turns right around and sends that into the eval library program, which changes that 2 from a picture of a 2 to a real live 2, and that gets stored in variable dog count over here. Remember, we don't want to just read in with input if we're reading a number, otherwise we won't be able to use what they type in arithmetically. We won't be able to use this 2 as a 2. It says dog count. There. Dog count. I'm going to read in 2. So far, so good, I hope. Another blank line in the code to make it look pretty. Line 21 says we're going to see an example of an if statement here. If dog count greater than 3. Now notice the sequence makes a huge difference here. I could not have done 22 earlier because I would not have had a value for variable dog count. So I have to read in a value first, and then if I want to take a look at it with an if or a while condition, I can do that. If dog count greater than 3. The current value of dog count is 2, and 2 is not greater than 3. So what does it not do? It does not print, wow, that's a lot of dogs. What it does do is just continue on with the program, as if that if statement hadn't been there at all. That's our first format of if. It's either do it or don't do it, but keep going. Straight line, no loop. So since dog count on line 22, since it was not greater than 3, it just skips over. Wow, that's a lot of dogs. That's all the indented statements that were under that if, and then it goes on to the next line. Another if. This one, starting with a comment on line 25, this is an if-else statement. If dog count is exactly equal to 1. Well, I guess that's strike 2 for us. Dog count is still 2. There hasn't been anything to change its value yet. 2 is not exactly equal to 1, so it does not print, does your dog have any playmates? On line 27. However, this is a format 2 if where there's an else part. So if the condition is false, which in this case it is, the condition is false, dog count is not 1, then it's going to do the else part and print out, do those, and then it prints out the value of variable dog count, which is 2. Do those 2 dogs get along? And that's just a rhetorical question. That's not a prompt, so we're not going to have the user type in an answer there. They couldn't even if they wanted to, because that's not part of an input statement. It's just being polite. Do those 2 dogs get along? Okay, next up, another blank line to make it look pretty in the source code printout or on the screen. Line 31 says we're about to see a for loop here. Now, this print statement, that does go to the beginning of the next line. So now we're going to see a separate line on the screen. All the blank lines in the code, remember, all the blank lines in the code just show up in the code. They don't actually affect what shows up on the screen. If I have an empty print statement like line 32, that's going to put a blank line on the screen before it shows any more output. Now then, dog number, a brand new variable. Dog number. Dog number on line 33 is set to value 0. Then we start a while loop, and it's very important to take what I call almost a blinders on, very local view of what's going on. In other words, don't take a holistic view and say, well, you know what, I think that while loop is looping through all the dogs. Yeah, that's what's going on. That's not healthy. The healthier way is to take this the way the CPU would look at it, one little line at a time. Don't look forward, don't look back, don't look anything. So here's the current state of what's going on in the program when I get to line 34. And now I'm not going to think about what dog number really means and what dog count really means. That's for later on when I'm trying to analyze the program for updating it or whatever. But line 34 says, while, and then test the condition. Is it true that dog number is less than dog count? Dog number is 0, and yes, in fact, that is less than dog count. 0 is less than 2. So it is going to do the indented statements that start on line 35. There's an input statement on the right-hand side. Remember these assignment statements with single equals. They always start on the right-hand side. Right-hand side, what's your dog's name? I'm going to guess there was a question mark and a colon and a space. Yes. Question mark, colon, space. We'll make it crystal clear to the user they're expected to do something now. What's your dog's name? And let's say that the user types in Leo. And they have to press enter or we're not going to be able to see Leo. They get done with their typing and press enter and now it's ours. That's read in with the input statement. You'll notice that does not have a val. We're not going to try to turn Leo into a number. We read that in and put that into a variable called dog name. So Leo is read from the keyboard and put into variable dog name. All that happened on line 35. Remember that those input statements are a combination of output and input. Their output is to print the prompt on the screen. The input is to read what comes in from the keyboard and put it into a variable. Now we generate some more output and we'll say, we'll do some praise here. Good dog. Oh, with a capital D, of course. Good dog, comma. And then it prints out the value of variable dog name, which is currently Leo. Follows it with an exclamation point. Must be a very good dog. Then, moving right along, one line at a time, line 37. Don't even look at the left-hand side. Pretend it's not even there yet. On the right-hand side, we want the value of that expression. Dog number plus 1. Dog number is 0. I can do that math in my head. 0 plus 1 is 1. So the value of the right-hand side of that assignment statement is 1. Now I can look at the left-hand side, put it in variable dog number. So it, in effect, bumps up dog number from 0 to 1. That's the end of the indented statements inside the while loop. It automatically, this is easily the most important difference between a while statement and an if statement. On a while statement, it automatically goes back to the top of the while loop, and the CPU will look at line 34 all over again. like it's never been there before. So on line 34, when it comes back up and tests that condition again, is it true that dog number is less than dog count? Is 1 less than 2? In fact, it is. 1 is less than 2, so here we go again, and it does the indented statements all over again, just as if it's never been here. It doesn't even know it's been here before. And then we hit line 35, an input statement. What's your dog's name? Gets printed on the screen. Colon, space. And we sit there on line 35. It doesn't go one step further until the user answers the prompt. What's your dog's name? Maybe the user types in Darby, presses enter so that the computer can see it. Then the CPU will take what's come in from the keyboard and put that in variable dog name. So dog name Leo is gone. It's been replaced with Darby. Now remember, these struck out values over here, that's an optical illusion. There is no ghost of Leo in this variable. When Darby gets copied over variable Leo, Leo's out of here. Leo's gone. And if we want to get Leo again, we'll have to ask for it again and read it in from the keyboard or something else, because there's no way to go backwards. There's no undo on a variable value. Okay, where are we? We just now read in Darby on line 35 and put it into variable dog name. So now we're ready for line 36. And it will print out good dog with a capital D, then a comma, and the dog name is now Darby, and then an exclamation point. A print statement itself will automatically go to the next line, but it won't skip any blank lines. So if we wanted to put blank lines between these down here, we'd have to have some more empty print statements. Okay, that was line 36. We hit line 37. I'm not even going to say again, we don't know that we've been here before. The CPU doesn't know that it's been to this statement before. All it knows is it's doing as it's told, one line at a time. The control unit says, okay, it's time for you to do this line. Yes, control unit. Here we are back on line 37. The right-hand side of line 37 says, get the value of dog number, that variable, plus 1. The value of dog number is 1. 1 plus 1 is 2. So the right-hand side of the assignment is 2. And it's still just kind of floating out there in a register. It's not in a variable until it hits the left-hand side of the assignment statement, and it copies that 2 out of a register into the memory location that we have affectionately named dog number 2. That was the last statement inside the indented statements of the while loop, line 37, so it goes back up. Goes back up to line 34. While loop goes over and over. Is it true that dog number is less than dog count? Dog number is currently 2. I would have put these in a column marking them out. This is kind of messy right here, but I didn't account for space in advance. My bad. This should have been value mark out, and kind of a column here. But dog number is 2. Is it true it's less than dog count, which is 2? No, that's false. They're equal. If they're equal, the first one's not less than the second one. Dempster rules. So what does it do? Well, the while loop condition is false, so it skips over the indented statements. It falls out of the while loop and goes to the next line. Whatever follows the indented statements, the next line is line 38. Have a nice walk. Exclamation point. And then there is a print down at the bottom to make it look nice and pretty before it gives us our return message or whatever it's going to do at the end. And main, actually we were doing line 41 the whole time. We wouldn't have gone through the program at all if line 41 had not been there. What else is there to say? Well, here's a couple of things to say. This is one of approximately an infinite number of different execution paths through this program. When we got to line 22, for example, dog count was not greater than 3. It could have been. They could have typed in 6. If they had typed in 6 for dog count on line 19, then it definitely would have said, wow, that's a lot of dogs. It still would not have done the does your dog have any playmates on line 27, but it would print out, do those 6 dogs all get along? And then it's going to drag you through the for loop. I mean, not the for loop, the while loop. You can tell. You can predict this now. You can tell that it's going to go through the while loop 6 times, 1 for each dog. If you don't believe me, Trace through it just like we did just now with different values of the variables to try to solidify, make concrete what's going on in this program. It's not enough. You could view this as the computer equivalent of a French class. It's not enough that you're just able to kind of halfway express yourself in French to other people and feel like you're special. You have to be able to understand what other people are saying to you. As we're going through Python, you've got to concentrate not just on, okay, how am I going to write this to do what Dr. England asked me to do in my program? You've also got to be able to read existing code and make sense out of it. It's a two-way street. Input and output. You have to be an input and an output device. See how this all fits together in a neat little package? At any rate, what else is there to say about it? Oh, line 37. Yeah, that caught my eye. Line 37 is important. One of the special notes about while loops is if the condition is true the first time, there's got to be some way that it will eventually become false by executing the inside of the loop, also known as the body of the loop, the indented statements. So if line 37 hadn't been there, we would be an infinite loop and this program would never stop. That's bad. We don't want that to happen. If you come up with other questions, you can send me emails, you can ask me during office hours, you can ask me during class. But you better ask me, because if there's any part of this that doesn't make sense, we need to clear that up post haste. And I'll see you online.